Hey everyone, question 4.3a wants to know the maximum number of real roots a polynomial of degree 3 can have. So a polynomial of degree 3, if we just did a basic set of zeros and you had 3 separate zeros there, I'm not going to sketch it here, but I have it on Desmos. Okay, the question I did was, the equation I did was x minus 2 here, x plus 3, and x minus 5. So as you can see, look where the hand's pointing on the x-axis there. Negative 3, 0 is one of the zeros because negative 3 plus 3 is 0. Positive 2 is one of the zeros because 2 minus 2 is 0. And positive 5 is one of the zeros because x minus, or 5 minus 5 is 0. Sorry guys, I have a cold, so maybe coughing or sneezing or sounding funny. So those are the 3 places it's going to cross the x-axis. It can have a maximum of 3 right here. And I know that this is positive, which means it's going to go down on the negative side, but it's going to go up on the positive side because each of my x's here are positive, right? When I multiply those together, my x cubed is going to be positive. And that's what a positive cubed root looks like. But what if I changed, what if I changed this to be, I'll take away the x minus 5, and if I do that, now I only have 2 zeros, but it's also degree 2, it's a quadratic. But what if I square this second term? Okay, if I square that second term, that means that there's only 2 zeros because it's only going to touch negative 3 one time, or it's going to touch negative 3 one time, even though it's a degree 3. So if we look at it now, okay, the maximum was 3. It could also touch twice, and if we did this, if we take away this and we make this into a cubed, okay, it's going to only touch once, even though there are technically 3 zeros right there at negative 3, 0, it still is only 1 point, okay? Now, with something that's degree 3, because it's an odd degree, one side is always going to be going down and one side's always going to be going up. Because that's the case, anything that has an odd number degree has to touch at least once. Right? And that is not the same for something that is just, we could have a parabola, right? If we just do x squared, that's a parabola. And that touches once, but we can also, let's say we move this parabola up to, we can also have it not at all go through that x-axis. Okay? So because it's an even degree, it can have 0 roots. But an odd degree always has to have at least 1 root, okay? So B, what do you think is the maximum number of roots that a polynomial of degree n can have? Well, n's the maximum number. We don't know what it is. Can a polynomial of degree n have fewer than n real roots? Yes, we just talked about that. Oops, sorry guys. Sorry. Can a polynomial, oh, D. A squared factor produces a double root, for example. Okay, yep, we talked about that. That's what we just did. I'm so smart. X equals negative 5 is a double root, so good. They're using vocabulary I didn't use. What effect does this squared factor have on the graph? Word. P of x equals x minus 2 times x plus 4 cubed. What effect does a cubic factor have on this graph? Okay, so this is degree 4. And it says it has a cubic root. So my guess is that it's only going to cross one time, but let's put this into Desmos. X minus 2 and x plus 4 cubed. X minus 2 times x plus 4 cubed. Okay, so we're looking at that purple line. So even though this is a quartic, which means 4 roots, 4 degrees, function, okay, it's only going to cross the x-axis twice because there's only 2 zeros. Look how much we know. We're so smart. Okay, arrow down. And those were all positive. Whoops. Examine the sketches of the polynomial functions below. For each polynomial function shown above, state the minimum degree and its equation can have. Explain how you know. Okay, so this is something to the 4th power. So the minimum degree is going to be 0 because we could draw our axis, our x-axis down here, right? And it is never, ever going to touch. The same for 2. We can draw it here, and it's never, ever going to touch. Here, if one side's going up and one side's going down, remember that goes up and down forever, we could draw the axis up here above all of those, okay? Or we could draw it down here below all of those, but it's always going to cross at least once or intersect at least once because it ends up going up one way and down the other way. So the minimum number would be 1. Whereas here for the even functions, it's going to be 0. Question C, can 2 be a polynomial of degree 5? No, 2 cannot be a polynomial of degree 5 because it has to be an even number because they're both pointing the same way. They're both going the same direction. And it says, can the equation of graph 2 be a polynomial of degree 4? Yeah, it could be a polynomial of degree 4 that has just 2 zeros, so 2 things being squared. What would that look like? Let's see, x plus 4, let's change this to be x plus 4 squared and x minus 2 squared. Oops, oh, that didn't do it. Let me do one that does it. Let's just make one of these zeros, whoops, one of these zeros to the 4th power. I bet that will help. Delete, delete. I bet that will do it. Okay, there is just a regular parabola, but let's just take that to the 4th power. Okay. So it kind of looks like a parabola if we zoom out enough. It does seem to be a little bit less of a curve there, but I bet we could fix that by changing like the A value there. All right, and on the test, on the quiz, there's just going to be a bunch of kind of pictures like that you have to figure out. Under what circumstance can the curves that look the same represent polynomial functions of a higher degree? Oh, if like 3 of the zeros are the same 0, then it's just going to look like 1 0, even though it's actually 3 zeros, right? So I showed you guys that. All right, I'm going to stop this video here, but I'm going to do some of the review preview as videos too. Thanks.